Alright, this will be the second part of 5.3. We're going to do one more problem from the second section dealing with reference angles. Let's try cosecant of 150. Okay, so first of all, cosecant of x, the reciprocal function to cosecant is sine. 1 over sine is cosecant. And we know on the unit circle, sine of some angle is the y value, the y coordinate. So 1 over sine becomes 1 over y. Cosecant will be 1 over the y coordinate. Thus, in our particular case, cosecant of a 150, if we weren't asked to use the reference angle, we could simply find the y value of that 150 degrees, looking at our unit circle, coming to 150 degrees, which is also 5/6 radians. I want the y coordinate. In this case, it's 1/2. So sine would be 1/2, but cosecant is the reciprocal. The reciprocal of 1/2 is 2 over 1. So we can see cosecant of 150 is 2 over 1, which is 2. That's pulling it directly off, but it's asking it for us to use the reference angle. So we're going to go back and look at a blank unit circle here, and we'll get a better idea about this reference angle. That 150 degrees is measured from the positive x-axis. That's 150 degrees. Well, the reference angle is the angle between the terminal side, this is the terminal side, and the x-axis. This is the reference angle. This large angle is 150 degrees. The reference angle here is 30 degrees. What we're saying is this 150 degree angle will behave very similar to this 30 degree angle over here because it has the same. That is the meaning of this reference angle. These two triangles are congruent. This triangle here and this triangle here are congruent. This length here will be identical to that length there in length and in sine because they're both a positive y value. However much this side is, this side will be exactly the same. These x's on the other hand, they're of the same length, but they will be different signs. This one will be positive. This one here will be negative because it's in the negative direction. So we are concerned with cosecant, which is 1 over sine, which is dealing with the y coordinate. Since we're dealing with the y coordinate, this value is going to be precisely the same as that value because they're both in the positive direction. So cosecant of a 150 degree angle is going to be exactly the same as cosecant of a 30 degree angle, which is going to be the same as 1 over sine of a 30 degree angle. All of these are going to be 2. And I'm going to use a grapher or just our calculator to assess this. Cosecant of 150 degrees. It's going to be 2. There we see it. Now I can evaluate cosecant of 30 degrees. It's also going to be 2. Exactly the same. And now I will evaluate 1 over sine. There we go. And that is 2. the ratio of the vertical distance over the hypotenuse being 1, so it's just the y coordinate, or 1 over y in the case of cosecant. All right, so that's how you handle 18 through 37. Now we'll look at problem number 38. It says, if sine of t is 3 over 4 and t is in quadrant 2, find cosine, secant, cosecant, tangent, and cotangent. We did one like this in the previous section. So draw yourself a second quadrant angle where sine of t is 3 over 4. So we're going to draw ourselves a second quadrant angle. First quadrant, second quadrant. So we know this is the angle here that we're dealing with, but it's going to have the same, the reference angle is this one right here. So we'll call this our angle T. We'll draw ourselves a right triangle. Sine of T, and sine is opposite over hypotenuse. Sine of t is equal to 3 over 4. So 3 over 4 is the opposite over the hypotenuse. So from t, the opposite is 3. It will be positive because it's above the x-axis. The hypotenuse is 4. So we need to find this other side. As a radical expression, that's the hypotenuse. So question mark is going to equal the square root of 4 minus 4 squared, minus 3 squared. Hypotenuse squared minus leg squared. Well, 4 squared is 16. 3 squared is 9. 16 minus 9 is 7. That's this side here, square root of 7. Now, since we're in the second quadrant, here's our origin. This distance right here is towards the left, so this is negative square root of 7. So we're ready to find all of our values now. Cosine is adjacent over hypotenuse. So from our angle T, the adjacent is the negative square root of 7 and the hypotenuse is 4. Negative square root of 7 over 4. That is the cosine of T. Tangent is opposite over adjacent. Tangent is opposite over adjacent. So from T, the opposite is 3. The adjacent is negative square root of 7. This is 3 over negative square root of 7. Now we should rationalize our denominator, but we're going to leave it like that for right now. It's going to help for the rest of this problem. Cosine tangent. Next we have secant. Secant is the reciprocal of cosine. And so we're simply going to flip over this fraction here. Thus, it is, typically we express the negation with the numerator. So I've just flipped over this fraction. I expressed the negation with the numerator. And I didn't do that in this case, but it would be the same thing. I could write this as negative 3 over square root of 7. The value's the same. All right. Cosecant is the reciprocal of sine. So we're simply going to flip over our initial fraction. Our initial one was 3 over 4. So cosecant is going to be 4 over 3. Lastly, cotangent. Cotangent of t is the same as 1 over tangent of t. So I'm flipping over tangent. So this would be square root of 7 over -3. Said another way, negative square root of 7 over 3. Lastly, we should rationalize these couple of fractions that need it. This one, we should multiply by the square root of 7 over square root of 7. Square root of 7 times square root of 7 is 7. -3 times square root of 7 is -3 square roots of 7. And similarly, this one, I mean, I'm sure that you can see the pattern based on that one. It's going to be -4 square roots of 7 over 7. This problem, and we showed this the other day, can also be solved with our Pythagorean identity. Remember, this is going to be a fundamental identity. Cosine squared x plus sine squared x is equal to 1. This is directly from the Pythagorean theorem. Remember, cosine is x and sine is y. What we have here is x squared plus y squared is equal to 1. You could consider this 1 squared. 1 squared is 1. This is a squared plus b squared is c squared, where c is 1. It's our unit circle. So we can use this identity to solve this. I'll show it in this particular context. We had the original problem tells us sine of t is 3/4. So cosine squared x plus remember when we say sine squared x, this is another way to say sine of x quantity squared. In our particular case, sine of x is 3/4. I'm going to substitute 3/4 in there. Okay, so this becomes plus 3/4 quantity squared is equal to 1. Squaring a fraction, you square the top and the bottom. Subtracting 9 over 16 on both sides, we get cosine squared x. If you subtract 9 over 16, you're left with 7 over 16. Taking the square root of both sides, you're left with cosine x is equal to square root of 7 over the square root of 16, and the square root of 16 is 4, so we have the square root of 7 over 4. But we know it's a second quadrant. We know it's second quadrant, and in the second quadrant, y is going to be positive, but x is going to be a negative. And since cosine is x, then this must be negative square root of 7 over 4. So you can see that's exactly what we got using the triangle method. Negative square root of 7 over 4. Either of those methods will do. 52 through 59, super simple. You're just using the calculator. 49 through 51, you're using the unit circle in the other direction. So here you're going to take the coordinates they give you and come up with what this angle is. Since this is square root of 2 over 2, this angle T must be 45 degrees. You're just working backwards on the unit circle. No problem at all with those. 62 through 69. 62 through 69, it says use identities to evaluate the expression. So what you want to do is back up in the book, and also in the Google Classroom, there is a thing that says unit circle and trig cheat sheet. This will be very useful. The trig cheat sheet. This is a lot of identities. It's different properties about sine, cosine, tangent. But I'm going to, you can reduce it by looking at the ones in this particular section. So this blue section here on page 478, these two blue sections are going to be pretty valuable to us. this bottom section that has the inverse, the reciprocal relationships are useful. And this particular one for this problem. All right. We're looking at this fact that tangent is equal to sine over cosine. This makes sense. Tangent is opposite over adjacent. Sine's opposite over hypotenuse. Cosine adjacent over hypotenuse. The hypotenuse is canceled to leave this sine over cosine is opposite over adjacent. So we're going to use this fact. Tangent of t is sine t over cosine t. T just being some arbitrary angle like x or theta we often use. Using this fact to solve problem number 62. All right, they tell us that tangent of t is about 2.7. Sine of t is approximately 0.94. So the question is, what is cosine of t? All right, we'll use the identity we just saw, that tangent is equal to sine over cosine. Substituting what we know tangent is about 2.7. We know sine is 0.94. And we're looking for cosine. I'm just going to call it question mark. All right. When the variable is in the denominator, multiply by it on both sides. So now we have 2.7 question mark is equal to 0.94. Solving for question mark, we'll divide by 2.7 on both sides. So question mark is whatever 0.94 divided by 2.7 is. Looks like about 1/3 probably. .35. All right, with that you should be able to deal with most of the problems on this assignment.